Hey guys, I've already done this video once today, but I wanted to do it again. I didn't especially like the last one. There's a couple things I felt like I could have taught a little bit more in depth. So let's make another video. Cool. All right. First off, let's see. Let's go ahead and read this. The palace, the Palace of Peace and Accord in Astana, Kazakhstan was built in 2006. The building has a right square-based pyramid structure. The length of a side of the square base is 62 meters, and the vertical height of the pyramid is also 62 meters. So we know that the length of all the bases is 62 meters. Okay, so this is 62 meters. Everything's 62 meters all the way around the base, all right? Now it mentions the vertical height is 62 meters. Well, what is the vertical height? The vertical height simply is it just goes straight from the tip of the pyramid to right to the very middle of the square base. Okay, I think that intuitively kind of should make sense to you. And then, so this is the triangle we're looking at right here. Okay, all right. Now, so let's see. Okay, so it tells me that this edge of the triangle, the vertical height is 62 meters. Okay. All right. So I'm going to go ahead and I'm going to redraw this triangle right here. Okay. I'm going to put it over here. Here's the vertical height. Okay. This is 62 meters. Now we don't know what this is yet. And we don't know what this is yet, right? We do know this is a right triangle here. This vertical height, it makes a right angle right there. Okay. We also know that this hits right in the middle of this square. This makes sense to me. If this is a square base and each one of these equilateral triangles hits perfectly in the middle, it would make sense to me that the vertical height would hit right in the center there. Okay, so maybe visualize it a little bit, but all of these sides come off of a perfectly square base where all the sides are exactly the same. So it's going to make 1, 2, 3, 4 equilateral triangles that come to a point up top. So it makes sense to me that it would hit in the middle here. But what I wanted to do is I wanted to draw the base, okay? Let's just say I draw the base of this pyramid, okay? We know it's a square. All right. I want to convince you of this side right here. We need to find this side on the triangle. Okay. This side, right? Well, this is the square base here. We know that this is 62. We know the whole base is 62, right? So if I were to cut this base in half, each side, let's just pretend, let's just draw a line right down the middle of the square, okay? I'm going to cut this side in half and I'm going to cut this side in half. That's going to give me 31 on this side and 31 on this side. It's going to give me 31 on this side and 31 on this side. Now, let's cut this side down the middle. That's going to make this 31 and this 31. This 31 and this 31. I think it intuitively makes sense here that this right here is also good. All of these on the inside will also be 31, right? We cut it in half, cut this in half, everything's 31, okay? So that puts the center here at 31 away from the middle here, right? So that means that this edge is 31 meters, 31 meters. So now we just need to do the Pythagorean theorem. 31 squared plus 62 squared equals L squared. This is 961. This is 3844 equals L squared. 384. Let's see. I'm going to pop my calculator up. I forgot to write these down. Boom. Clear. 961 plus 3844 equals, okay, square root of 4805 equals. That puts L, that makes L, or the slant height, 69.32. 69.3. 69.3 meters. 69.3 meters. Okay. All right. Hopefully that makes sense. I know it makes sense.